Hello students, welcome back. Today we will continue with exercise 4.1 of chapter number 4, that is principle of mathematical induction. Till our last video we had completed till question number 8. So let's begin with question number 9. Question number 9. You have to prove 1 by 2 plus 1 by 4 plus 1 by 8 up to 1 upon 2 raised to n is equal to 1 minus 1 by 2 raised to n. Okay. So now we will use the same basics, that is first for p of 1. So 2 raised to 1 1. So this up to first term. LHS is equal to 1 by 2. RHS 1 minus 1 by 2 raised to 1. So that will be 2, and that is also equal to 1 by 2. So LHS is equal to RHS, hence P of 1 is true. Let's name this as 1. Okay, now let P of K be true. Our second step, let P of K be true. Okay, so that means 1 by 2 plus 1 by 4, 1 by 8 up to 1 upon 2 raised to k. This will be equal to 1 minus 1 upon 2 raised to k. Okay, so now for our third step, for p of k plus 1, we have to prove 1 by 2 plus 1 by 4 up to 1 upon 2 raised to. Now instead of n, I will use k plus 1. This is equal to 1 minus 1 upon 2 raised to. Instead of n, I will use k plus 1. Okay. Now we have to prove this. Now let's take LHS. Okay, before 1 upon 2 raised to k, the term before it will be 1 upon 2 raised to k. So that is this one. So let's take its RHS, that is 1 minus 1 upon 2 raised to k plus this last term 1 upon 2 raised to k plus 1. Okay, so now 1 minus 1 upon 2 raised to k plus. Now I can split this power. I can write it down in this way. 2 raised to k into 2 raised to 1. Clear? So now let's take 1 upon 2 raised to k common. See, 1 upon 2 raised to k, and this is also 1 upon 2 raised to k. So 1 minus 1 upon 2 raised to k. So what is remaining here? In this, nothing. So 1. Here, plus. Actually, it will be minus because here there is a plus sign. So minus minus plus 1 upon what is remaining? 2. Clear? I will carry it forward here. So LHS will be equal to 1 minus 1 upon 2 raised to k into 1 minus 1 by 2, that will be equal to half. When I remove half from 1, it is half. So it is 1 by 2. So I can write down this in 1 minus 1 upon 2 raised to k into 2. So 2 raised to k plus 1. 1 minus 1 upon 2 raised to k plus 1. And that is our RHS. Okay. So this is third. So from 1, 2 and 3, n is p of n is true. Sorry, according to principle of mathematical induction. According to principle of mathematical induction, P of n is true for every n belonging to n. Clear? What we did? First we checked for P of 1, it was true. Then we assumed that P of k is true, and using that we had proved that P of k plus 1 is true. Right? So according to the principle of mathematical induction, P of n is true for every n belonging to n. Clear? So that was about question number 9. So just note it down. Now let's move to the next, that is question number 10. Question number 10. 1 upon 2 into 5 plus 1 upon 5 into 8 plus 1 upon 8 into 11 up to 1 upon 3n minus 1 into 3n plus 2, that is equal to n upon 6n plus 4. Okay. So now let's take for p of 1. For p of 1. So 3 into 1 minus 1, that is 2. 3 into 1, 3 plus 2, 5. So the first LHS is equal to 1 upon 2 into 5, that is equal to 1 upon 10. RHS, that will be equal to N, that is 1 upon 6 into N, means 6 into 1, 6 plus 4, 10. So see here, LHS is equal to RHS, hence P of 1 is true. Okay. Now for P of K, let P of K be true. Let P of K be true. So 1 upon 2 into 5 plus 1 upon 5 into 8 up to 1 upon 3k minus 1 into 3k plus 2. This is equal to k upon 6k plus 4. Okay, let's take this as number 2. Okay, we had assumed that this is true. So now for p of k plus 1, we have to prove 1 upon 2 into 5 plus 1 upon 5 into 8 plus 1 upon 3. 3 into k plus 1 means 3k plus 3 minus 1. So it will be 3k plus 2. And here same thing, 3 into k plus 1, 3k plus 3 plus 2. So that is 3k plus 5. And you have to prove this is equal to, instead of n, k plus 1 upon the 6 into k plus 1. Okay, 6 into k plus 1, that will be 6k plus 6 plus 4, that is 6k plus 10. Okay, so now let's take LHS. We will use our shortcut. Before this term it will be 3k minus 1, 3k plus 2, so this one we'll use k upon 6k plus 4 plus 1 upon 3k plus 2 into 3k plus 5. Clear? So now this will be equal to k upon, if I take here 2 common, it will be 3k plus 2 plus 1 upon 3k plus 5, sorry, 3k plus 2 into 3k plus 5. So I can take 1 upon 3k plus 2 common, okay, into k by 2 plus 1 upon 3k plus 5. So I will carry it forward here. LHS will be equal to 1 upon 3k plus 2 as it is. I will multiply this 3k into k, 3k square. 5 into k, 5k. Plus this side 1 into 2, 2 upon 2 into 3k plus 5. Okay, so this will be equal 1 upon 3k plus 2. Now 3 2s are 6, so I need to split this 5, right? I can split it in this way: 3k square plus 3k plus 2k plus 2 upon 3 2s are 6k plus 5 2s are 10. Okay, so this will be equal to 1 upon 3k plus 2. I will take 3k common, so it will be k plus 1 plus 2 common, k plus 1 upon 6k plus 10. Clear? So this will be equal to 1 upon 3k plus 2 into 3k plus 2, k plus 1 upon 6k plus 10. So 3k plus 2, 3k plus 2 cancel. And this is equal to RHS. Okay, so from 1, 2, and 3, according to principle of mathematical induction, P of n is true for every n belonging to n. Clear? So this was about question number 10. So just note it down. Now let's move to the next, that is question number 11. Question 11, 1 upon 1 into 2 into 3 plus 1 upon 2 into 3 into 4 plus 1 upon 3 into 4 into 5 up to 1 upon n plus 1 n plus 2, that is equal to n plus 3 upon 4 into n plus 1 n plus 2. Okay, so first we will see for n plus 1. Sorry, for p of 1. What is LHS? 1 upon 1 into 2 into 3, that is 1 by 6. RHS is equal to 1, n plus 3 means 1 plus 3, 4 upon 4. M plus 1, 1 plus means 1 plus 1, 2. M plus 2 means 1 plus 2, 3. This is also equal to 1 upon 6. So P of 1 is true. Okay. Now let P of K be true. So what does that imply? 1 upon 1, 2, 3 plus 1 upon 2, 3, 4 up to 1 upon n, n plus 1, n plus 2, that is equal to n, not n, sorry, it's k, that is equal to k plus 3 upon 4 into k plus 1, k plus 2. Okay, now for kp of k plus 1, we have to prove 1 upon 1 into 2 into 3 plus 1 upon 2 into 3 into 4 up to 1 upon, instead of n, k plus 1. For n plus 1 means k plus 1, k plus 2. And n plus 2, k plus 1 plus 2, k plus 3. So this is equal to, instead of n, k plus 1. n plus 3 means k plus 1 plus 3. That is k plus 4 upon 4. K plus 1 plus 1, k plus 2. K plus 1 plus 2, k plus 3. Okay. Now let's take LHS. We will use the shortcut. We will use the RHS of number 2. That is k plus 3 upon 4 into k plus 1, k plus 2 plus the last term of this equation, 1 upon k plus 1, k plus 2, k plus 3. Okay, so k plus 1, k plus 2, k plus 1, k plus 2, I will take it as common. Okay, so this will be equal to k into k plus 3. So let's take k square plus 3k upon 4 plus 1 upon k plus 3. When I carry it forward here, LHS is equal to 1 upon k plus 1, k plus 2. Now when I will take LCM, I will multiply it. 4 into k plus 3. Okay, so now k into k square, k cube plus 3k into k, 3k square plus k square into 3, 3k square, 3k into 3, 9k plus 4 ones are 4. So this will be equal to, or let us solve this separately. So this is k cube plus 3k square. Okay, it's k cube plus 3k square plus 3k square, 6k square plus 9k plus 4. Sum of odd term, coefficient of odd term, 1 plus 9, that is equal to 10. And 6 plus 4, that is equal to, sum of odd term is same. That means k plus 1 is factor. That means k plus 1 equal to 0, k equal to minus 1. So now let's take the coefficient 1, 6, 9, 4. As k plus 1 equal to 0, k equal to minus 1, I am putting here minus 1, 0. 1 into minus 1, minus 1. 6 minus 1, 5. 5 into minus 1, minus 5. 9 minus 5, 4. 4 into minus 1, minus 4, 0. So this will be equal to k plus 1 into k square plus 5k plus 4. Clear? Okay. So now let's see the LHS. This will be equal to 1 upon k plus 1, k plus 2, it's 4, and k plus 3. The numerator, this will be equal to k plus 1 into k square plus 5k plus 4. So k plus 1 gets cancelled. Now k square plus 5k plus 4, when I will split 5 such that its product must be 4 and sum must be 5, that is 4 ones are. So this will be again k plus 1, k plus 4 upon k plus 2, k plus 3. Okay. So when we will see this, this is equal to RHS. Okay. We missed this 4. So now this is equal to RHS. So let's name this as third. From 1, 2, and 3, according to principle of mathematical induction, P of 1 is true for, sorry, P of n is true for every n belonging to n. Clear? This was about question number 11. So just note it down. Okay, so that was about question number 11. Now I'm giving you few sums for you to do it for yourself. Question number 15, 16, and 17. These three sum of exercise 4.1 I am giving you for yourself. Okay, so try by yourself. So I'm giving you hint in 15th. In all these three questions, our first step will be P of 1. Okay, and that will be, you will find out that LHS will be equal to RHS. So P of 1 will be true. For second step, you have to assume that P of K will be, P of K is true. Okay, and in third you have to prove for P of K plus 1. Clear? So in 15th you will get this type of equation in terms of K, like K 2K minus 1, 2K plus 1 upon 3 plus the RHS, that will be K plus, sorry, 2K plus 1 whole square. Okay, so now what you can do, I'm giving you hint, after this step you can take 2k plus 1 from here and 2k plus 1 from here. Okay, you can take common and then take LCM and then add it and try to reach to the RHS. Clear? Similarly in question 16 also, what you have to do, you will get such this term as 1 upon 3k minus 2 into 3k, not 1 upon, my mistake, k upon 3k plus 1 plus 1 upon 3k plus 1, 3k plus 4. Okay, and then you have to solve this. So here what you can do, you can take 1 upon 3k plus 1 and 1 upon 3k plus 1 common. It will be k plus 1 upon 3k plus 4. Then take LCM and try to reach to the RHS. Okay, And similarly, also try for question number 17. Yeah. So, okay, students, that's it for today. Thank you.